Hi, this is Asutosh and welcome once again in this course of indefinite integrals. And we are now in lesson number 15, and that is splitting into two. So this is the sub technique of substitution, in which we are going to split a given integrand into two different integrands. So let us understand how the integrand should look like to do this. So the integrand form should be px plus q over ax square plus bx plus c, or px plus q over square root of ax square plus bx plus c, or px plus q over times square root of ax square plus bx plus c. So we can say precisely that it is like a linear by a quadratic, a linear by a root quadratic, or linear times root quadratic. So any of this situation, in any of these situations, we have to do two things. The first one is we have to express the linear in terms of derivative of the quadratic. It means we should write a linear is equal to lambda times derivative of quadratic plus mu. So this is the main idea, and of course after starting with this, we can find the value of lambda and mu, because it is assumed value. They are actually arbitrary constants, and we can compare the both hand sides, the coefficients of x and x square as well, and then we can find the value of lambda and mu. And after that we will substitute back this px plus q in this form into the integrand, and from there we will split the integrand into two, and the first integrand will lead us to do the direct substitution, and the second integrand will lead us to completing the square, which we have discussed in the previous lesson. So let us understand how we can apply this into the example. So suppose I have the integrand as 3x plus 1 over 2x squared plus 6x plus 5. So you can see that this is linear over quadratic. So the first task is to express this 3x plus 1 in terms of derivative of the quadratic. So for that we should start with this 3x plus 1 is equal to lambda times the derivative of the quadratic and plus mu. Now after just differentiating this, we can get 4x plus 6, and the other things will be remain same. And now we are in situation to compare the coefficients of x and the constant term from both hand sides, and for that we should collect all the coefficients together and the constant term together. So after collecting them, we will get what? It is 4 lambda x here, and here this will be 6 lambda plus mu as the constant. So now we can compare the coefficients of x to get 4 lambda is equal to 3, and again the 6 lambda plus mu is equal to 1, and from here we can get lambda is equal to 3 by 4, and of course substituting this lambda here, we can get the value of mu, and mu will be this will become 3 by 2, so 9 by 2, 1 minus 9 by 2, that will be negative 7 over 2. So lambda and mu is known now. We can substitute it back into this equation number 1, and we can get 3x plus 1 as 3 by 4, 4x plus 6 minus 7 by 2. Now this linear term is expressed as the derivative of the denominator. So we are in situation to substitute back into the integrand. So the numerator can be replaced with this 3 by 4, 4x plus 6 minus 7 by 2. And what is the splitting into 2? Now here comes. We can simply split this entire integrand into two integrand, like this 3 by 4 is a constant, so we can take it out, and so it will be 4x plus 6 over 2x squared plus 6x plus 5, and the other one will be 7 by 2 times the integration of 1 over 2x squared plus 6x plus 5. So there are two integrand. If we can see that the first integration will be for this one, and we can assume this as I1 and this can be I2. So we have the I as 3 by 4 I1 minus 7 by 2 I2. So if we are able to find I1 and I2, we can replace it back here and that will be the final answer. Now you can see it clearly that the first integrand can be easily handled, and this first one is very easy. Why? Because this is 4x plus 6 over a square root, 2x squared plus 6x plus 5, and since the derivative of a denominator was deliberately made, therefore it is very easy to substitute this denominator as t. So this t is equal to 2x squared plus 6x plus 5, so we will immediately get the derivative in the top, and so this will be dt by dt, and the answer is ln t plus c1. So that will be always in this form, ln t plus c1. And you can observe that in the guideline also this is given as the direct substitution will be the first integrand, and now the second integrand, which is here I2, and this is 1 over 2x squared plus 6x plus 5, and for this we have to complete the square, or we have to express this quadratic as the sum or difference of two perfect squares, what we have done in the previous lesson. So for that we want to make the leading coefficient, that means the coefficient of x square is 1, and for that we have taken these two common, and so we will have x square plus 3x plus 5 by 2, and of course you know how to do that, so I have written it directly, x plus 3 by 2 the whole square, and that will be 1 by 4 after evaluating it. So this will be the integrand now. So the integration will be now half tan inverse x plus 3 by 2 over 1 by 2. After further simplification you get I2 as this. Since I was 3 by 4 I1 minus 7 by 2 I2, we have evaluated I1 here, and the I2 is here, and we can simply substitute both of the I1 and I2 in this equation, and we get the final answer as it. So this is the whole process of splitting into two. Now you understand the first integrand will be very easy by direct substitution, and the second integrand will be dealt with the concept of this completing the square method. Let us try to do this problem, and this time I want to just give you the technique of the technique of writing the numerator in terms of the derivative of denominator without going to the method of finding lambda and mu. So suppose I want to write this x plus 2 as x squared plus 2x plus 2 and plus mu, the derivative of this, and we will have now x plus 2 as lambda times derivative of this one, and that will be 2x plus 2 and plus mu, and we have to find lambda and mu. So of course without finding this lambda and mu, we can simply write it. And what we can do for it, suppose this, the derivative of x squared, let me just erase this thing and then it will be easy to show you. So let me, okay, it is not going to be erased, I think. Okay, it's not going to be erased, so let us understand this way. So first of all you write the derivative of 2x square, x squared plus 2x plus 2 at the top, and this is what, 2x plus 2. So assume that I have written this first. Now I have to make this 2x plus 2 as I have to express this 2x plus 2 as x plus 2, means I have to make this 2x plus 2 x plus 2. It means the coefficient of x is here 1, so I should divide with half this whole expression, and we will now have this x but an extra term 1, and this 1, and if I add 1 again you will get 2, so I have added this 1 here. It means without going by the process of finding lambda and mu, you can easily do this, and after that you can split it into the two integrands, and further you can find the integrations. So that is the answer. So that is the method of splitting into two, and it is very easy because we know all the two integration process comes in the way. The one is direct substitution, then the other one is completing the square. So the only main method, or sorry, the only main step is to find this lambda or mu, or I can say writing the numerator in terms of derivative of the quadratic term in the denominator, or wherever you see the quadratic. So that's all for today's lesson, and in next lesson we are going to do some other stuff in the substitution. Thanks for watching.